Welcome, everyone, and thanks for listening. I'm confident that what we have for you today is a great discussion on a really exciting topic. Recent events around the world have taught us that processing and interpreting volumes of data is important to both business continuity and enhancing end user experiences. Enterprises are turning to AI, machine learning, and analytics to make the right inferences from that data. So here I'm going to talk about how enterprises are challenged to get that important AI project into production while satisfying all the requirements for being deployed across multiple environments with security and manageability. So I'm going to start with talking about some challenges and a strategy. So organizations around the world apply AI technologies today to transform business in ways that will reinvent how firms win, serve, and retain customers. Businesses are under pressure to evolve quickly and optimize processes, maximize revenue streams, track trends, and develop new business models using digital technologies. AI has emerged as a core capability which every organization must leverage in order to be an industry player. It takes leadership, a knowledgeable workforce, and a mix of the right tools to see success. But an AI infrastructure is also required to expand and infuse that intelligence into practical use cases. So I'd like to start with the baseline set of assertions. The first one is that the upsurge of data does not automatically translate into business improvements without leveraging AI and machine learning to turn that data into insights. That may be obvious, but getting there can be a rocky road. The second is that businesses will increasingly leverage machine learning as more data is collected through IoT sensors, edge devices, and cloud sources. Machine learning is how we discover patterns in massive amounts of data and make inferences based on those patterns. The third introduces what I call practical AI, where AI ML is used to gain insights and infer something that becomes more useful in everyday life. Where the unexpected is inferred, which results in positive outcomes, I refer to this as practical AI. And that leads into the fourth assertion that I have here, that practical AI strengthens the trust people start to have in it. This shines a light on dark data and leads to decisions that can positively affect not only our businesses, but our everyday lives. The AI has emerged as rapidly becoming instrumental in driving the insights that empower businesses in today's connected world. Organizations today need to find complex relationships in large amounts of data and predict things that either cut costs or create value. AI can help minimize mistakes, reduce the probability of human error, and improve overall business efficiency. AI helps customize and automate large volumes of data and content, which has the capacity to improve productivity and creativity. Before we can start reaping the benefits of AI, there are some obvious factors that organizations should consider along the journey. The first is strategy. In order for people, process, and technology to function seamlessly, an AI strategy must be clear, concise, and adaptable. Second is people. The right people with the right digital skills are critical to successfully leveraging AI technology to transform the business. And talent can make or break digital transformation objectives. The third is process. It's no surprise that firms of all sizes are facing a lack of both a well-curated data to train AI systems and formalized processes to assess key business challenges. And the last one is technology. On one hand, AI needs the utilization of other technology tools to execute its tasks efficiently. On the other hand, it requires employees to trust that technology. AI can drive the insights that empower businesses as long as we can overcome this technology barrier. So AI success requires a formalized investment strategy. The first step on the left is to consider or understand how and where data is being captured and stored. For data analytics, we need to understand where the analysis will occur and how much data movement might be involved. Are these high performance environments, edge, cloud, hybrid, on-premise? How will the data be used? To get to an end game where we have a production-grade AI project that generates iterative insights that feed into business decisions, it all starts with data science and modeling. Predictive modeling that relies on machine learning or even deep learning will eventually lead to unexpected inferences that could have a major impact on the business and the services provided. This is, again, practical AI that can be trusted and can positively affect everyday lives as well as businesses. For people here, we also need to ensure the right skills are available that can leverage AI technology and eventually transform the business. Whether you need to develop these skills in-house or hire in some data scientists or get advice from outside consultants and suppliers, it's pretty likely that your workforce will need to adapt to handle this. The chart here shows a good list of skill sets that would be useful for AI, from the data analyst to the engineers to the data scientists, and it includes everything from statistical programming to machine learning techniques to data visualization. So the process to achieve a production model is key to eventually improving efficiencies in business and in IT operations. AI is like an iceberg where everyone focuses on the visible top layer, the shiny application layer, but forgets what is under the water, the big part. That's seen as simply an infrastructure problem: how to get data, how to clean and prepare the data, how to build models into production-ready artifacts, how to manage workloads and scalability. But the goal here is to eliminate that complexity of the AI infrastructure through a more holistic approach that spans from services to infrastructure to support. The challenge is to get the AI project into production while satisfying all the requirements for being deployed across multiple environments with security and manageability. Data scientists are not infrastructure experts, and DevOps operators are not AI experts per se. The data scientists need workflows that can be changed as the underlying hardware changes. Data scientists and AI operators need software building blocks and guidance on deployment, as well as how to manage remotely. So for technology, ultimately, it comes down to technology and the tools and packages that will be used to unlock the insights from the data analysis. An AI stack such as what is shown here provides a guidepost that businesses can use in developing the right environment and models for AI projects. There are many technology decisions to be made along the way. Starting at the bottom of the diagram, what hardware platforms and accelerators are available to you? Where will your analytics applications be deployed, monitored, and managed? How will the data be collected and analyzed? What additional infrastructure or container orchestration and management might be needed? For application orchestration, how will your pipelines and workflows be developed and validated? And also, what additional machine learning or neural network libraries and tools will be needed in developing AI containers? Once you have these building blocks and this end-to-end technology guidance, you can achieve a more optimized infrastructure for your AI project that fits within your architectural environments. So now let's look at a few use cases and industry scenarios. So in this one, the ultimate goal of incorporating AI in consumer goods businesses is to enable simpler and more direct shopping for both the producer and the consumer. And for things like appliance design, ultimately using an AI and HPC infrastructure for simulations and modeling leads to faster time to value with highly effective virtual design spaces. In manufacturing, this saves time and saves money because prototypes are built once the design validation has been performed and not earlier in the software. Customer satisfaction is improved with higher quality products that include more customer design features. The predictive analytics capabilities enabled by AI can provide manufacturers with plant-wide collaborative visibility of all of the work going on in process and provide insight into possible bottlenecks and pain points. And by taking advantage of predictive analytics, some of the highest impact developments have been in quality control, predictive maintenance, and supply chain optimization. In logistics and delivery, money is saved because packaging and product design innovations substantially reduce shipping damage, resulting in fewer returns. AI helps develop leaner, more optimized operations and personalized customer experiences. And in advertising, machine learning can provide a more personalized, contextual, and anticipatory experience when making a purchase. Digital interactions currently influence more than 1/3 of retail in-store sales. Targeted advertising using machine learning improves the quality and personalized nature of the ads based on buyer behaviors. Next is energy. The energy production portfolio is diversifying, and we are witnessing the ramifications of fossil fuel consumption on biodiversity, air quality, and the quality of life. And using AI and machine learning, simulations and modeling help reduce the cost and risk of future operations. In this industry, AI ML is revolutionizing the way we produce, transmit, and consume energy and helps to limit environmental impacts. And this helps to optimize supply and demand and enables proactive maintenance. Energy smart grids powered by AI ML continuously collect overwhelming amounts of data from millions of smart sensors nationwide to make timely decisions on how to best allocate energy resources. In the automotive industry, software-defined vehicles incorporate AI in many ways. In designing the vehicle itself, a high-performance computing environment is used to run simulations and performance tuning throughout the process. AI lends itself perfectly to powering advanced safety features for connected vehicles. The application of AI cloud platforms and services ensures that data is available when needed. For driving monitoring, AI detects driver behavior in 4 key areas: driver identification, recognition, monitoring, and infotainment control. And for car manufacturing, robots are driving optimizations and the rethinking of processes and product in innovative new ways. AI is not only changing what a vehicle can do, it is also changing how vehicles are being built. Researchers and scientists use powerful HPC clusters to perform advanced materials research. Very strong yet lightweight materials are crucial to automotive and aerospace manufacturers, particularly if they are used in extreme temperatures. Developing such materials requires a deep understanding of their underlying properties, and understanding those properties requires time-consuming computational processes on a massive scale. AI can mine databases for recipes to make the materials. AI ML predicts which compounds can create materials before setting foot in a lab. And algorithms can predict which compounds combine to form interesting new materials. And modeling helps quickly map out exactly what makes a material so much stronger or lighter. In the pharmaceuticals industry, machine learning predicts treatment results, matching drug interactions with patients, and it automates work that previously involved trial and error to match drug interventions with individual patients. Machine learning in drug design, discovery, and origins virtually combines atoms to generate new molecular structures. A deep learning neural network application helps improve structure-based drug design and discovery, as well as find the biological origin of a disease. Other companies are combining AI and DNA analyses to discover ingredients in different food sources that have therapeutic qualities, including the management of chronic metabolic diseases. So AI initiatives are being used throughout the pharmaceuticals industry today: precision medicine, drug discovery, and health data applications. Now let's quickly look at how we can address the challenges. An AI orchestrator is fundamentally a tool that removes the friction associated with creating, testing, and deploying machine learning models across multiple AI development, training, and execution platforms and frameworks. It relieves the data scientist of the burden of translating a data model into the execution steps of a particular AI pipeline or workflow. An AI orchestrator also opens new avenues of collaboration between the data scientist and the AI operations team by enabling the appropriate AI platform. This ensures project costs remain predictable while slashing the often weeks-long delay in execution that all data scientists really dread. So in summary, we want to approach AI ML application development and deployment using orchestration tools to help us assemble all the building blocks we might need. Eventually, we will have containerized and high-performance AI that will be deployed across multiple environments. That's the end game. To get there smoothly, our data scientists use optimized templates to jumpstart the workflows and the configurations. Pre-built automation workflow simplifies the project, and guidance through partner stacks for AI help drive the AI operator through the whole deployment experience. The end result is an accelerated project for AI and machine learning with a tested and a manageable solution. So in conclusion, throughout the development process, your data scientists will need easy access to packages important to AI. This helps establish the virtual machines configured to run the machine learning applications. So just a few of the AI packages are shown here, including Kubeflow projects for building machine learning pipelines, TensorFlow for machine learning, Jupyter for building AI models, Caffe is a deep learning framework, Keras is a Python deep learning API, Julia is another programming language for numerical analysis and computational science. Onyx is used in machine learning modeling. PyTorch is a modeling platform for machine learning. And R and Python are programming languages used frequently within statistical computing and science. So a lot of packages there, there's a lot more. And the idea is to bring them all together through the orchestration techniques that we just talked about. So again, thanks for listening to this AI and machine learning discussion. And I hope to get a chance to talk to you more about it in the future. So have a great day.